Aim, how do we differentiate between ground state electron configurations? So guys, this is atomic structure day 4. All right, let's go over it right here. Let's do it now. You can hit pause and answer the 3 do not questions, and then we'll go over it. Okay, we're back. So let's look at the first question here. It says, which notation represents an atom of sodium? Sodium is symbol Na, it's on the periodic table, or table S, which tells you all the names and so on and so forth, with an atomic number of 11, okay, and a mass number of 24. Well, we learned that the mass number goes on top, the atomic number goes on the bottom. So the answer is simply going to be choice 1. Number 2, which 2 nuclides are isotopes of the same element? Okay, well, we learned that isotopes are elements, first of all, they're the same element that have same number of protons or same atomic number, different number of neutrons, or different atomic masses on top. So which element has the same protons and different neutrons here? Well, first of all, choice 1 cannot be the answer because that's Na and Ne, no good. K and Ca, different elements, no good. C and N, no good. It says the same element. So same protons, different, when you subtract them, neutrons. So it's choice 3. Okay, let's move on to the next one here, please. What is the total number of neutrons in an atom of aluminum 27? Well, we learned that when it says 27, that is the mass that's given to you. That's the mass you use. 27. Now, you need to go to your periodic table. So hit pause, go to your periodic table, look at the atomic number of aluminum. Okay, we're back. The atomic number of aluminum, which is Al, is 13. So over here, to get the number of neutrons, right, it says here the number of neutrons. Neutrons, you simply subtract 27 minus 13, which would give me 14 neutrons. All right, let's move on. Now, if you ever seen this funny movie, well, it's actually a pretty crazy movie. There's a character here by the name of Tony Montana. Tony Montana is being played by the actor Al Pacino. So the question is, what state is Tony Montana in? The ground, relaxed state, or excited state in this picture? Well, Tony Montana looks pretty relaxed. So he's what's called in the ground state. Okay, let's move on here. So guys, let's go over ground state electron configuration. Right here, what I have here, okay, I have 4 elements here. Lithium, sodium, potassium, rubidium, okay? So these are 4 elements given to you here. All right, I tap in and take pictures of the periodic table so you have to keep going back and forth. Now, it says over here, ground state electron configuration. The ground state electron configuration is when an electron is at the lowest energy level. So where we find them? Well, all electron configurations that are ground state are found in the periodic table, okay? So let's look at the first element over here, please. First element again was lithium. Now let's go through this box again. The top number is the mass. So if I round 6.941 to the nearest whole number, that's going to be 7. The bottom number is the atomic number, the number of protons. Now look underneath that. Well, I see 2 numbers there. It says 2-1. Well, that tells me, according to your periodic table key, says that's called the electron configuration. Okay, so the electron configuration is there. So this 2 tells me that in the first level / shell, there are 2 electrons, which is right there. Now look at the second number, the second level of shell. Well, the second level of shell has 1 electron. So second level of shell equals 1 electron. Now, let's think about it. What does 2 plus 1 equal? Well, 2 plus 1 equals 3. Well, doesn't that 3 match the atomic number? Yes, because what did we learn, guys? We learned that atoms are electrically neutral. So if the atomic number is 3, that means you have 3 protons. How many electrons do you need to make it neutral? Well, 3. That's why, very simple, the electron configuration on the bottom, the ground state electron configuration there, always adds up to the atomic number above, okay? So guys, when you go to your periodic table, that number, the numbers you find at the bottom of each element's box are the ground state configuration. Let's do the next one here, sodium. Sodium has how many levels or shells here? Well, it has 1, 2, 3 levels or shells. 2 electrons in the first, 8 electrons in the second, 1 electron in the third. This represents the ground state configuration. Again, why? Because I found this configuration on your periodic table. Okay? Let's look at potassium. Potassium has 1, 2, 3, 4 levels of shells. Okay? 2 electrons in the first, 8 in the second, 8 in the third, 1 in the fourth. So the ground state configuration for potassium is 2881. Okay? Last one here is rubidium. Guys, all I'm doing is simply going down the periodic table in group 1, which is the only left-hand column going down. This has how many shells here, or levels? 1, 2, 3, 4, 5 levels of shells here. And again, 2 electrons in the first, 8 in the second, 18 in the third now, 8 in the fourth, and 1 in the fifth, okay? So again, any one of these configurations you find in the periodic table represents the ground state configuration. Done, let's move on. Okay. Excited state configuration. All right. So now, imagine yourself sitting at home, which most of you are during the pandemic. So most of you guys are remote. The excited state configuration is similar to when you wake up in the morning, you're exhausted, you're tired. So what do you want to do? Well, you want to either drink orange juice, coffee, anything that gives you either sugar or caffeine. Okay? The reason why you do that is to wake yourself up, to make you excited. Similar to an electron, guys. For an electron to be in what's called the excited state, okay, the excited state is not the ground state. The ground state is a relaxed state. The excited state is when an electron absorbs energy and jumps up to a higher energy level. Okay? So now, I'm looking at sodium over here. Let's look at sodium, guys. I took a picture of sodium from your periodic table. This is what it looks like here. Sodium has a configuration of 2-8-1, right? We learned that this is the ground state because this is what I found on the periodic table. We also just learned that there's 2 electrons in the first shell, 8 in the second, 1 in the third. Okay, so let's go back to the definition for excited state. It says when an electron absorbs energy and jumps up to a higher energy level. Okay, so let's look over here. Normally, when the electrons jump up, they're going to jump up from the second to last level to the last. So the second to last level here is the second level. The last level is the third level. So this electron will simply jump up. So when an electron leaves 8, well, 8 minus 1 will become 7. And the 1, if it gains 1, will now become 2. This is the excited state configuration. Okay? Now the question is this. What is 2 plus 7 plus 2? Well, 2 plus 7 is 9. Plus 2 is 11. So it still adds up to the atomic number of 11. It's just, does this configuration match what's on the periodic table? No. So remember, the periodic table is the ground state. Whenever the configuration adds up to that number but does not match it, that must be the excited state. So remember, the excited state must always contain the same number of electrons as a ground state. In this case, it's 11. Okay, let's do some examples, guys. All right? Practice questions here. All right. So hit pause and do these yourself if you can. And then we'll return. Okay, we're back. Let's do the first one here, guys. Magnesium. Magnesium says configuration of 282. Now remember we said that is a ground state because I found this on the periodic table. Okay, I just took a picture of it and simply put it in here. So now, excited state is when one electron jumps up from usually the second to last level to the third. So it's simply going to jump up from here to here. So what's my new configuration going to be? Well, my new configuration is going to be 2-7-3. That is the excited state. Okay, try zinc now on your own. Hit pause and try zinc. Okay, we're back. So zinc has 4 levels here, right? 2 electrons at first, 8 in the second, 18 in the third, 2 in the fourth, all right? So if you look over here, the second to last level will be the third. So 1 electron from 18 will jump up to the fourth, which has 2. So what is my excited state configuration going to say now? Well, it's going to say 2-8 well, 18 lost 1, so that becomes 17. And the 2 gain 1, that becomes 3. Now, if you add them up, guys, they're still going to add to 30. It's just the excited state does not match what's found in the periodic table, which is a ground state. Okay? Arsenic, which is a poison, usually found in rat poison, stuff like that, okay, has the ground state configuration 2-8-18-5. So please write right now the excited state. Hit pause. Okay, we're back. So that's, again, the electron jumps from the second to last, in this case the third level, to the fourth. So that can be 2-8-17-6. Very good. The last one is tellurium, which has 5 levels of shells there. 2-8-18-18-6. Again, the electron will jump from the second to the last. So it jumps from here to here. 2, 8, 18, 17, 7. That is the excited state configuration there. All right, let's move on. Bright line spectrum. So guys, you notice over here I have the colors of the bright line spectrum over here, right? Roy G. Biv, red, orange, yellow, blue, green, blue, indigo, violet. So now, the bright line spectrum says over here, right guys, look up in the sky, you see the sun. The sun emits light, visible light. We have artificial light sources in your house, light bulbs, so on and so forth. How is that produced? Very simple. Well, when an electron, we said before, absorbs energy, it jumps from the ground to the excited state. Now, does anything stay excited forever? No. Eventually, the electron will fall back from the excited state to the ground state, releasing energy. So, bright line spectrum light is when an electron in the excited state releases, another word for release, guys, is emits energy and falls back to the ground state in the form of light. Okay? You need to memorize that. It's going to be on your test. It'll be on a Regents exam, New York State Regents exam. Okay? All right, here we go. Let's look at this simple question over here. You'll see what I'm talking about. Page 63, 64 diagram below, which shows bright line spectrum selected for selected elements. Very simple. Guys, just like all of us have our own DNA, each element has its own bright line spectra. Okay? Now, these wavelengths or spectra are shown below. We have 4 elements given over here. We have lithium, hydrogen, helium, sodium, and the other element, the 5th one, is unknown. In other words, we don't know which one that is. So we need to figure out which elements make up that element, okay? The question 63 says, identify 2 elements in the unknown spectrum. Okay. Guys, all we have to do is to match the lines up with the unknown. Okay, let's see. Does lithium match up with the unknown? No. So lithium is gone. Bye-bye. Let's erase that. Okay, next, hydrogen. Does hydrogen match up with the unknown at the bottom of the lines? Well, let's see. Yes, it does here. Yes, it does here. So hydrogen, what else? Over here as well. and over here as well. So yeah, so hydrogen is one of the elements. Okay, so that's all right. Okay, let's do the helium. Well, does helium match up the unknown on the bottom? Matches here, 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 matches here. It's got to match all the way, guys, here and here. Yes, it does. Helium matches up. So those are your two answers here. Sodium does not match up because sodium's over here, okay? It does not match up the unknown. So the answer simply there is hydrogen and helium, okay? That's all you got to do is match up the lines, okay? All right, let's look at the question below, number 64. Explain how a bright line spectrum is produced in terms of. Guys, whenever you see the word in terms of, that word, those words must be in the answer. I see excited state, energy transitions, and ground state. So your answer must have excited state, the transition, is it falling back, is it jumping up, and ground state, okay? Well, let's see. We said this before. How's a bright line spectrum produced? It's produced when an electron falls from the excited to the ground state. So this is your answer up here. That's all you guys simply write is that. Okay? Yeah. Well, yes. Let's move on. Try this example yourself. I'm listening. I'm listening. Okay, what's it phone number? What's their phone number? Yeah. Okay, thank you very much. All right, let's do this question here, guys. All right. So it says here, which elements are present in this mixture here? All right. So let's look over here. Now, this question here requires us to look at the bright line spectrum for the two elements. So let's look at the numbers here. Well, this one's at 650, 660, 670. So we need to go up to 670 here. Here is 670 right there. Well, A matches up here. No, that doesn't match up down there. So A matches up for 670. Let's look at the next one here. 610. Here is 610. A matches up there. X matches up there. So far A and X. But X hasn't matched up yet other places, so we don't know about X yet. Next, 590 and like 585. Well, here's 590, here's 585. So it's right there. Okay, so D. Now, let's see, 500. Well, that's A. X doesn't match up here, no. So X cannot be the answer. It's got to match up the whole way through. So it's going to be simply be A and D.